Hello everyone. In mensuration 1 we have learned two-dimensional figures. Square, rhombus, circle, triangle. We have learned the areas and parameters of these figures. Today we are going to start three-dimensional figures, that are 3D figures. That means 3 dimensions. Which figures have 3 dimensions? Length, breadth and their height. In 2 dimension you have studied that it has length and only breadth, and they are drawn on a piece of a paper. 3-dimensional figures are in a space. Space means you are having 3 dimensions, length, width and some height. So in 3-dimensional figures we are going to study the areas, that means surface areas. Surface area, that it is a 3D figure. What is the surface area of that? And volume. Surface area and volume of these figures. Okay, these are 3D figures. So volume is the space occupied by the object. Okay, a capacity of the object. Volume is capacity of the object. Like that is a cylindrical glass. So a cylindrical glass, how much water does it contain? This is the volume of the glass. Okay, so we will study surface area and volumes. So let us take first cube and cuboid. We will study all the solid shapes. So first let us see cube and cuboid. After that we will learn cylinder, cone, sphere, hemisphere, frustum. We will do all the figures. These are 3D solid shapes, that is cube and cuboid. So cube, you have seen a playing Rubik's cube. Rubik's cube you have seen. So that has all same dimensions. So if length of this is A, breadth is also A, and this height is also A. If length, breadth and height all are same, that is a cube. Cube is made up of squares. Some kind of squares like, and cuboid. Cuboid is of the form in which length, breadth and height are different. Okay. Suppose this is length, this is height and this is breadth of the cuboid. So हमने क्यूब में हमारे पास सारी डायमेंशंस सेम होती हैं, 3 dimensions. All the 3 are same. Here 3 dimensions are not same. So let me show you cuboid. This is a cuboidal box. This is a cuboidal box in which this is length and the breadth and this is the height of this box. So length, breadth and height of the box, these are having 3 dimensions. So this is a cuboid. Like our cuboidal room. Cuboidal room has length, some breadth and height. So if length and breadth and height of the objects become same, then it is known as, these cuboidal boxes are made up of rectangles. If you see the surface, this is length and breadth. Length and breadth. That means this is a rectangle. This side is also a rectangle, and this side is also a rectangle. So these cuboid, it has 6 faces and all the 6 faces are rectangular in shape. So it is made of, all the 6 faces are rectangular, and here all the 6 faces are square. Okay. So if this is cube, then total surface area of cube, total surface area of cube. Total surface area means all the 6 faces of the cube. Okay, this cube is having 6 faces, 4 at the 4 corners, 1 at the top and 1 at the bottom. It has 6 faces, so 6 into a square, that is face of a square. 6 faces have the same area, that is 6 into a square. Okay. Another, in this we calculate lateral surface area. Lateral surface area of cube, that means these four faces of the area of these 4 faces of the cube or cuboid means lateral. You will not take top and bottom. So for lateral surface area we get 4a square, only 4 sides of this cube. So area will be 4a square. Okay. What will be the volume of cube? Volume of cube, the capacity of this box. Okay. What will be the capacity of this box? A cube. Okay. How? There is one general formula for volume. ठीक है, volumes are calculated by some general formula, that is base area into height of object. This is the general formula for volume. Base area into height. This is the general formula for volume, that is base area into height. So in this case, base is a square and height is a. So we get here is, this comes from base area is a square and height is a. So we get a cube. Okay, in this way we calculate the volume of cube. Now let us see cuboid. All the 6 faces. So let us see total surface area of cuboid. Total surface area of cuboid. Okay, total surface area of cuboid. What will be the total surface? First of all, we will see 4 faces of the cuboid. Let us see this. This is length and breadth. Okay, this side. And this same face is same to the another side, that is length into breadth. These 2 faces are same of cuboid. These 2 faces are same. These 2 faces are same. And these 2 faces are same. So it is having length into breadth, length into height, breadth into height. Okay, so we will take, they are 2 into length breadth. As we know, area of rectangle is, length into breadth. Okay, and we know here is area of square. Okay, rectangle will be length into breadth. So twice of length into breadth, because we are having 2 faces same. Okay, similarly plus area of another, breadth into height plus length into height. All the 6 faces area is covered. So this is the total surface area of cuboid. What will be the lateral surface area? Means all the sides. Lateral surface area. Lateral surface area means we will not take the top and the bottom. The bottom has length into breadth and same top has length into breadth. So we will not take length into breadth. What we will take? We will not take this. We will take BH plus LH. Okay. From here we take H common and we get L plus B. So this is the lateral surface area of cuboid, all the 4 sides area. Okay. And similarly volume of cuboid will be base area into height. Here base is length into breadth. Base is length into breadth multiply by its height. So volume of cuboid is LBH, length, breadth into height. We get the volume of cuboid, that is the capacity of that cuboidal box. Okay. These are the formulas for cube and cuboid. In cuboid we take the basics of square. Okay. Square. Each side is a square. Each face of the cube is a square. And in cuboid each face is a rectangle. So we use rectangle formula and find the total surface area, lateral surface area and the volume of these 3D figures. Now let us see cylinder. And what is basically a cylinder? It is of the shape this. This is the cylindrical shape, circular at both ends of some radius r and height h. So this is a cylinder. Okay, in some questions you will see that find the volume of cylindrical glasses. Okay, so how you have to take is, like this is a cylindrical glass. It has some height and both the sides are circular. So this is a cylindrical shape glasses. Okay, so similarly this is a cylinder. So total surface area of cylinder will be total surface area. What will be the total surface area of cylinder? Will be 2 pi RH plus 2 pi R square. How come? This is the curved surface area of cylinder. Curved means curved portion of this cylinder. Suppose this is a glass. So curved surface area will be this area. You will not take the top and not bottom. You will take only curved area. So that area of the, you say that curved surface area. Curved surface area curved surface area of cylinder is 2 pi RH. Okay, so what will be total? Total surface area will be curved plus top pi r square, area of circle pi r square, bottom area of circle pi r square. Pi r square plus pi r square give you 2 pi r square. So total surface area of cylinder is 2 pi RH plus 2 pi r square, and curved surface area is 2 pi RH. Okay, and the volume of cylinder is base area into height. Base area into height. What is base area? Pi r square. This is base area into height gives you volume of cylinder. Okay. Please keep your notebooks and make the table of this total surface area, curved surface area and volume with the figures, so that when you learn from that, all the formulas are together. Okay. So make the proper table side by side. Now let us see cone. Cones are a shape of your birthday caps. Okay. So this is the shape of the cone with some radius and height. Okay. In the cone, this is the height of the cone, and this is called L. L is the slant height. In the cone, there is a slant height, radius and height. So there is one experiment that if there is a cylinder and there is a cone of same heights, suppose you fill the cone with water. Okay, so if you fill the cone with water and you put that water in the cylindrical container, then the water will be filled in the cylinder 1/3. That means you have to put 3 cones, fully filled cones, to the cylinder to get its volume. Okay, so if you are having cylinder and the cone of same height and radius, you have to fill 3 cones to get the capacity of the cylinder. Okay, so total surface area. First of all, total surface area of cone will be curved surface area plus area of base. Okay, what is curved surface area? This area, only curved one. That formula is pi RL for the cone, and area of base is pi r square because this is a circle, only one base. Okay, and curved surface area will be, curved surface area of cone is pi r L, and total is pi r L plus pi r square. What is the volume? So volume of cone is 1/3 of volume of cylinder. This is the volume of cylinder, 1/3 of the volume of cylinder. From the activity you can easily recall that 3 filled cones will fill the capacity of the cylinder. So 1/3 into volume of the cylinder. So this is the about cone. And if you have to find the slant height of this, if you have to find the slant height, then formula for slant height is r square plus h square. That means L is equal to under root of r square plus h square. That is by Pythagoras. Okay, because if this is h and this is r at 90, then you can find the slant height by Pythagoras theorem. So for L, the formula for L is this. Okay, and total is pi r L plus pi r square. Curved is pi r L. Volume of cone is 1/3 pi r square h. Okay, now let us see sphere and hemisphere. Okay, circle is a 2D figure. Okay, but sphere is a 3D, like your ball, your cricket ball. Okay, your basketball, volleyball. These are spheres. Here is the, so they are of same radius. Okay, so total surface area of sphere is, total surface area, there will be no curved surface area. Curved surface area and total surface area means surface area for the sphere. Surface area for the sphere is 4 pi r square. Okay, and volume of sphere is 4/3 pi r cube. This is the volume of sphere. That is capacity of the sphere is 4/3 pi r cube, and total surface area is 4 pi r square. What is hemisphere? Hemisphere, if you cut the ball from its half. If you cut the ball from its half, you get a hemisphere. Okay, like this. If you cut the ball from its half, you get a hemisphere. And for hemisphere, you are having total surface area is equal to 3 pi r square. Okay, because total surface area of sphere is 4 pi r square. If you cut the sphere from its half, you will get half of its area, that is 2 pi r square. Half of its area 2 pi r square. But for the hemisphere, you are having this circular top also. For the circular top, you are having 3 pi r square. 2 pi r square plus this top gives you 3 pi r square. So this is the total surface area of hemisphere. In hemisphere, you calculate curved surface area also. So curved surface area of hemisphere will be 2 pi r square. Only this curved portion. Okay. And what will be the volume? Volume of hemisphere will be half of volume of the sphere. So half of the volume, 1 by 2 of this. That means 2 by 3 pi r cube is the volume of the hemisphere. Okay. Now let us see what is a frustum. Buckets are the form of a frustum. Frustum is of form like this. This is a frustum. You are having the cone. This cone is of the shape this. So when you cut your cone from here, suppose you get a frustum. If you cut here, you remove this area. You are with this. This is the shape of the frustum. Okay, your buckets, in which there is the R1 radius of top, and R2 radius of bottom. R1 and R2 are radius, and this is the height. And this slant height is same both sides, L. Okay. So frustum is of this form. When you cut the cone from the top, you get a frustum. This is the shape of frustum. So radius of both the top and the bottom will be different. R1 and R2. This is the height and the slant height L of the frustum. So first you will have curved surface area of frustum. In the cone, curved surface area was pi RL. For cone, curved surface area was pi RL. Now the curved surface area will be pi L R1 plus R2, because you are having two radiuses. So this will be the curved surface area for the frustum. Total surface area will be curved surface area plus area of these two ends, top and the bottom, that is pi L R1 plus R2 curved plus pi R1 square plus pi R2 square. Or you can write it as this. You can take pi common, R1 square plus R2 square. This is the total surface area of frustum. Now volume of frustum will be one by 3 pi h R1 square plus R2 square plus R1 into R2. This is the volume of the frustum. So to calculate the volume of frustum, you need height and both the radiuses. Calculate the total curved surface area, total surface area and volume of frustum. Frustum is having at both ends radii are different. This is the height and this is the slant height. So we have done the basics of this three-dimensional figures. Now we will practice some questions relating to 2D figures, 3D figures and see how to apply these formulas on questions.